Okay, students, good morning to all of you. So, in last class, we were discussing about the objective of this one wave optics. Nana. No? Yeah. So, sorry, I have to share your PDF copy. No? Yes. It is opening, Nana. So, question number 18 over. Nana. Question number 18 is over. Yes. Question number 19 now. See, if the intensity of waves observed by two coherent sources is I, then intensity of resultant wave in constructive interference will be. So what is the intensity of resultant wave in constructive interference? See, in constructive interference, delta phi should be constant at zero, Nana. Clear? Yes. And resultant intensity formula is I1 plus I2 plus 2 root I1 under I2 cos of phi angle between the two intensities. No? And they are given that two intensities are same. Then the formula will become I is equal to I plus 2 times of I into I square cos phi. No? Yes, root square cancel. You will get I plus I is 2I plus 2 into I is 2I. Cos phi we can write. Yes. So this resultant intensity can be written as 2I take common, you will get 1 plus cos phi. No? Yes. Just remember this result, it will be somewhere, it will be useful for you. Very important result. You need to remember this. Okay, na? Or else it can be written as 2I into 1 plus cos theta, we can write it as 2 cos square phi by 2, we can write. Do you know this formula? Trigonometry? 1 plus cos theta can be written as 2 cos square theta by 2. So resultant intensity will become 2 to the 4. So 4I cos square phi by 2. Yes. Now, see, according to the question, if the intensity of two waves observed by two coherent sources is I, then intensity of resultant wave constructive interference. They have given that coherent sources. What are coherent sources? Coherent sources are nothing but the sources which are having constant phase difference, constant frequency. So phase difference will be 0. So if you keep 0 here, cos 0 is 1. So 1 into 4I is 4I. Yes. So your answer will be 4 times of I, Nana. Got it? Okay? Yes. Next question. If the intensity of each of the two waves is I and they are having phase difference of 1 by 2, 120. Phase difference how much, Nana? Delta phi is 120 degrees given. Okay. Now what they are asking? Then the waves are superimposed. The resultant intensity will be. So when the two intensities are equal, resultant intensity formula just now I have given that it as 2I into 1 plus cos delta phi. Yes or no? Or else it can be written as 4I cos square delta phi by 2. Okay? 4I cos square delta phi by 2. Correct? Yes. Any formula you use, you will get the same answer. So 4i into cos square of delta phi, how much given, Anna? 120. 120 divided by 2. 120 by 2 means 60 degrees. So it will be 4i into cos square 60 degrees. So 4i into cos 60, how much, Nana? Cos 60 is 1 by 2, no? Yes, 1 by 2 whole square. It will be how much? I. 1 by 2 is 4, 4 cancel. It will be I. So intensity how much, Nana? I. 20th question, intensity is I, Nana. Got it? Clear? Understanding, no, students? Next. Next question. Question number 21. See, read that question, Nana. Question number 21. What they have given? Question number 21 is the ratio of intensity of two waves. Ratio of intensities of two waves. The ratio of intensity of two waves is 25:1. If the interferences occur, then ratio of maximum to minimum intensity is what? See, Nana, just now I have given that intensity formula is I1 plus I2 plus 2 times of root under root I1 under root I2. So I am writing root of I1 I2 only. Okay, cos phi or cos delta phi. Okay, what is maximum intensity, Nana? Maximum intensity, how much you will get? Phi is equal to 1, means cos phi is equal to 1, then only you will get maximum intensity. It is in the form of I1 plus I2 plus under root of 2 under root of I1 I2. It can be written as root I1 plus root I2 whole square. No, yes, this modification already I have given you. And minimum intensity will be when cos delta phi is equal to -1, and it will be root of I1 minus root of I2 whole square. This is the minimum intensity. Remember these two formulas important again. Maximum intensity formula is this and minimum intensity formula is this. Okay, they have given that ratio of intensity of two waves is 25:1. Okay, so I maximum to I minimum they have given. How much it is? 25/1 given. Okay, no problem. Then the ratio of maximum to minimum intensity what? Okay, we want maximum to, ratio of intensity of two waves they have given, Nana. Ratio of intensities of two waves they have given. Ratio of intensities of two waves they have given. I1 and I2. 25:1. They are asking what is the ratio of maximum to minimum intensity. Okay, I maximum how much, right? I maximum is equal to root of I1 plus root of I2 whole square. No? Yes. I minimum how much, right? Under root of I1 minus under root of I2 whole square. No? Yes. Root of I1 value what, not 25, no? Yes, 25. Plus root I1 is 1 whole square by 25/1 means I1 by I2 is 25/1 means I1 value is 25, I2 value is 1. That is the meaning. Okay. Yes. Root 25 minus root 1 whole square. What is root 25? Root 25 value is 5, no? Root 25 value how much, Nana? Root 25 value is 5. Correct? Yes. So it will be I maximum to I minimum ratio will be, here I'll write I minimum to I maximum to I minimum ratio I am taking, Nana. Here I am writing. Okay. Yes. So this ratio will be root 25 is 5. Correct? Yes. So this is 5 plus root 1 is 1 whole square by root 25 is 5 minus 1 whole square. So 5 plus 1 is 6. 6 square upon 5 minus 1 is 4. 4 square. 6 square is nothing but 36. 4 square is 16. Yes or no? Yes. So divide this, 4 4 is 16, 4 9 is 36. So it is in the ratio of 9/4, means 9:4 option. Yes. Option 3 is there, 9:4. Got it? Answer? So formula for I maximum to I minimum is root I1 plus root I2 whole square upon root I1 minus root I2 whole square. This you need to remember. Got it? Students? Next, question number 22. The intensity of two waves is 2 and 3 units. Two waves intensities. I1 is 2 and I2 is 3 units. They are asking then average intensity of light in overlapping region. Yes, this question. Average intensity. What is I average? Average intensity what na? How much maximum intensity we are getting plus how much minimum intensity we are getting divided by 2. This is called as I average. No? Yes, you know. Okay. What is I maximum na? Root I1 plus root I2 whole square is I maximum. Correct? Plus I minimum how much ne? Root I1 minus root I2 whole square is I minimum divided by 2. This is called as I average. Are you understanding what I am writing there? Clear? I average is root I1 plus root I2 whole square, and I minimum means I root I1 minus root I2 whole square. Okay. Root I1 plus root I2 whole square can be written as I1 root I1 whole square. Plus I2 plus 2 root of I1 I2. Correct? Plus this formula can be written as I1 plus I2 minus 2 root I1 I2. Correct? I am applying A plus B whole square formula and A minus B whole square formula here and here divided by 2. This plus or minus cancel. You will get I1 plus I1 2 times of I1 plus I2 plus I2 2 times of I2 by 2. Take 2 common, they'll cancel. You'll get I1 plus I2. Yes, you need to remember this formula also. When two waves intensities are given, then what is the average intensity? Formula directly I1 plus I2. Remember important formula. Now I1 is given 2, I2 is given 3. So 2 plus 3 how much? 2 plus 3 is 5. So answer should be 5. Yes, option 3 is there 5. Got it, Nana? These all formulas, direct formulas are there in your material. Once you will read, you will get these all things. Got it? And point here you need to remember for a short answer is I average is equal to I1 plus I2. Sometimes they will give, sometimes here they have given intensities, sometimes they will give amplitudes also. We know intensity is directly proportional to amplitude. No? Yes, and clearly understand. We know intensity is directly proportional to amplitude square. Amplitude square. Correct? Yes. So I average how much? I average is equal to I1 intensity plus I2 intensity. It can be written as A1 square plus A2 square. Yes, when amplitudes are given, average intensity will be A1 square plus A2 square. You need to remember this formula and this formula, both important. Clear? Yes. Next, question number 23. The light waves from two independent monochromatic sources are given as y1 is equal to 2 sine omega t minus kx. Okay. Another wave is given as y2 is equal to 3 cos omega t minus kx. Okay. These are two, what they are given? Light waves from two independent monochromatic sources. Monochromatic means what? Single wavelength or single frequency are given. Okay. These are two waves are given. Now what they are asking? Both have same, both the waves are coherent sources. Is it correct? Both the waves are coherent sources they have given. Next, both the waves are incoherent sources they have given. Next, both the waves having different time periods they have given. None of the above. Yeah. So let us see first. Both the waves are different time period. See in this equation, t same means this is wrong. Both the waves are not having different wave time period. This is wrong. Next, they are given coherent sources. These coherent sources they are given. What is the meaning of coherent sources? The coherent sources are nothing but the two sources which are having same frequency or same wavelength of light. Correct? Yes. Can you say these two are coherent sources just by seeing these equations? You can't say anything until and unless you know about these omegas. Correct? Yes, because omega is equal to 2 pi f. No, if omega is different, f should be different. F is different means non-coherent, incoherent. F is same is coherent. But they are given just omega, omega. And one more thing here, sine is there, here cos is there. Then what to write? This cos can be written as 3 cos can be written as sine 90 plus theta. Means this two waves are having, this wave and this wave are having a phase difference of 90 degrees, but phase difference is not useful here, just they are asking coherent or not coherent. So for that you need to read question clearly. Question what they have given, light waves from two independent sources. See here, independent sources they are given here. Yes, you know, two independent sources can never be coherent because these two independent sources can send light of different frequencies. One cannot decide at what time they will send atom in electron in an atom goes to excited state. One cannot decide. So due to this reason, two independent sources can never be coherent. So we can say both the waves are incoherent without knowing these two equations. No need to see these two equations. Just they are given independent sources. Just by knowing this, sorry, just by seeing this, we can say they are incoherent. They are incoherent. So this is wrong. And none of the above also wrong. So right option is both the waves are incoherent. How I am giving this answer? Just I have read that they are independent sources from this point. What is, students? Very important point. These small logic questions, you should be careful about these questions. Okay. Yes. Next. Question number 24, Nana. Question number 24. Question number 24. What they are given? The phenomena of interference is shown by. Interference can be shown by any type of wave. Already I told you. Interference depends only on phase difference and amplitude. That's it. So longitudinal waves will show, transverse waves will show, electromagnetic waves will show. So answer is all the above. Answer. Already you know this point. Next, question number 25. For the sustained interference of light, the necessary condition is important for your board exam also they may ask. Necessary condition for the two sources should be, the two sources should be coherent sources. Sources which are coming from the two slits should be coherent. This is the main necessary required condition. So coherent sources means the phase difference or path difference should be constant. Okay, as option 1 is the right answer. So the two slits should be narrow. Yes, this is also required. Be scaled to each other. Yes, this two should be distance between these two slits should be very small, and amplitude should be same. Yes, this is required, but main requirement for that is coherent sources. Important. So 25th question, option 1 is right answer, Nana. Clear? Okay. Yes. Next question number 27. Let's go to next question number 26. See here, question number 26, Nana. If the ratio of amplitudes of two interfering sources is 3:5, ratio of intensity of maxima to minima is, okay. Ratio of amplitudes they are given, Nana. A1 by A2 given. How much? 3/5 given. Okay. What they're asking? Ratio of intensity of maxima to minima. Okay. I maxima by I minima ratio they are asking. Okay. Formula what, Nana? I maxima is nothing but root I1 plus root I2 whole square by root I1 minus root I2 whole square. No? Yes. As we know, intensity is directly proportional to amplitude square. That implies root intensity proportional to amplitude. Yes or no? Yes. That means this formula will become A1 plus A2 because they are under root whole square upon A1 minus A2 whole square. This point is important. Just remember this point, Nana, all of you. Point is important, remember this. So I maximum intensity by I minimum intensity, how much? I maximum is A1 is 3, A2 is 5 whole square by 3 minus 5 whole square. 3 plus 5 is 8, 8 square. 3 minus 5 is minus 2, minus 2 whole square is 4. Correct? Yes. 8 square is 64. 4. Correct? Yes. 4 ones are 4. 4. How much? 24 is there. 4 6 are 24. Yes. So its ratio is 16 is to 1. 16 by 1 or 16 is to 1. Yes. Option 3 is there. Option 3 is right answer. Got it, students? Understanding? No? Yes. Easy. Not easy. Easy means you should know the this concept. Then only you can solve. Okay, next question number 27. Two coherent sources of light beam of intensity I and 4I are superimposed. The maximum and minimum possible intensities in resultant is. Okay. See, two intensities are given. Resultant intensity formula is I1 plus I2 plus 2 under root of I1 I2 cos phi. Okay. Maxima intensity we will get, intensity maxima will get when cos phi is equal to plus 1. Okay, so resultant intensity will become, Nana, I1 is I given, I2 is 4I given, plus 2 times of I into 4I, cos phi is 1. So is equal to I plus 4I plus 4 under root 4 is there. It will come out as 2. 2 2s are 4 into I means I. So total is 4I, 4I, 8I, 8I plus I, 9I. Maximum intensity. This is maximum. Minimum intensity how much, Nana? Root I1 means I, I2 is 4I plus 2 times of root I into 4I. Cos delta phi should be minus 1 means this should be minus, this will be minus, then only it will be minimum intensity. So it will be I plus 4I, this is minus 4I, plus 4I minus 4I cancel, how much it is? I. So ratio of maxima to minima they are asking, maxima is 9I, minima is I, so ratio is how much? 9 is to 1, correct? Yes, 9I, 1I, yes. Fourth option. Again similar questions all. Okay, next 27 28. Two coherent sources of intensities I1 and I2 produce an interference pattern. The maximum intensity in the interference pattern will be how much, Nana? Yes, fourth option. It is a direct question. Root I1 plus root I2 whole square. Formula it is. Formula based question, no? Clear? Yes. Okay. क्लास चल रहा है बाद में क्लास टाइम లో సార్ అక్కడ ఉంటే కష్టం అయిపోతుంది క్లాస్ నెక్స్ట్ అన్న క్వశ్చన్ నంబర్ 29 రైట్ Question number 29. Two waves are represented by the equations y1 is equal to a sin omega t, y1 is equal to a sin omega t. Another equation is given as y2 is equal to A cos omega t. Then they are saying that first wave is leading by phase pi by 2, lags by phase pi by pi, leads the second wave by pi by 2, leads the second wave by pi by 2. Yes, just this can be known by knowing this phase angle between these two. So cos can be written as sine of 90 plus omega t. No, yes or no? Yes. Cos theta can be written as sine 90 plus theta. So y2 can be written as a sine omega t plus 90. Yes. Who is leading? Y2 is leading by 90 degrees. That means y1 is lags behind by 90 degrees. 90 degrees is nothing but pi by 2. Yes. So first wave is lags the second by pi by 2. Finish. Okay. Next question number 30. The resultant amplitude of vibrating particle by the superposition of two waves. Y1 is equal to A sine omega t plus pi by 2. Y2 is equal to A sine omega t. So from these two waves, what is the delta phi nana? Phase difference how much? Phase difference between these two is pi by 3. Correct? Means 60 degrees. Phase difference just by seeing these two equations. Yes or no? Yes. Then what they are saying? The resultant amplitude of vibrating particle by superposition of two waves. Okay. Resultant amplitude A resultant amplitude A resultant amplitude can be given as under root of a1 square plus a2 square plus 2a1 a2 cos phi nana. According to vector law, we can give. Okay. First wave amplitude how much? A square. Plus second wave amplitude how much also? A. So a square plus 2 times of a into a cos of 60 degrees. Correct? Yes. So root of a square plus 2a into a square cos 60 is 1 by 2 nana. So 2 cancel. Now you are having 3 times of a square, means 3a square we can write. That means it will be root 3 times of a. Yes, resultant amplitude is root 3 times of a. Yes, option 4 is there. Remember this also. Important. Here. Next. Question number 31. Question number 31, Nana. See, two coherent sources of different intensities send waves which interfere. Intensities are different. Intensities are different. Okay. If the ratio of maximum and minimum intensities in the pattern is ratio of maximum to minimum intensity in the pattern is how much given? 25. This is the ratio they are given. Okay. Then find the ratio of intensities. Find the ratio of I1 and I2 ratio you need to find. Yes. See, I max upon I minimum. Formula what na? Root I1 plus root I2 whole square. This formula, these all questions based on this formula only, but different type pattern of question. This ratio given as 25. So 25 is equal to root I1 plus root I2 whole square by root I1 minus root I2 whole square. This square, whole square we can write. Yes or no? Yes, we can write this as whole square. No? Yes, whole square we can write. This square, send this side. It will become root 25. Correct? Yes. Root 25 how much? Root 25 is 5. Correct? Yes. So what will be this? It will become what? See. Cross multiply this nana. Cross multiply ne? Cross multiply this, you will get 5 times of root I1 minus root I2 is equal to root I1 plus root I2. Correct? Yes. So it will be 5 root I1 minus 5 root I2 is equal to root I1 plus root I2. Yeah. So all I1 terms send one side. So 5 root I1 is there here minus root I1 is equal to root I2 is right hand side is there. This going to this side will become plus 5 root I2. 5 minus 1 is 4 I root I1 is equal to 6 root I2. Square on both sides will become 16 I1 is equal to 36 I2. So I1 by I2 ratio. What is I1 by I2 ratio? I1 by I2 ratio is 36 by 16. Yes, 4 4s are 36. Sorry, 4 4s are 16. 4 9s are 36. 9 by 4 means 9:4. Yes, option 3 is right answer. Just only the thing is you need to know the calculations. How to do? Means mathematics. Totally mathematics. Okay. Next. Okay. Next. Question number 32. What is the path difference for constructive interference? Sorry, destructive interference. Path difference, what they are asking. Destructive interference path difference is direct question, Anna. It is 2n plus 1 into lambda by 2. Direct question, Anna. Okay, na? It is a direct question. Next, 33. If an interference pattern have maximum and minimum intensities 36:1, then ratio, what will be the ratio of the amplitudes? Same question as our 30th question, like that. You solve it, you can get this answer. Homework I am giving. Okay, it is same question. When a thin transparent sheet of thickness t and refractive index mu is placed in the path of one of the two interference wave, then the path difference will be, see here, this is YDSC experiment setup. These are the two slits S1 and S2, and here there is a screen, capital D is there. Okay, here we will get a central maxima. We'll get central maxima here. So when two rays are like this, they are traveling, we'll get somewhere else here y distance, we'll get a maxima. That y distance is n lambda capital D by small d. You know these all things. Now what they are doing, they are keeping one slit here in the path of one ray. They are giving one slit having refractive index and thickness. Then due to that slit, what is the path difference here? Remember, path difference is mu minus 1 into t, Nana. Very important. I have given you this while I am explaining the concept. So answer is mu minus 1 into t, Nana. Very important. Path difference due to thick plane sheet is mu minus 1 into t. Optical path difference, I have explained this. Okay, mu minus 1 into t, Nana. This already we have discussed. Next, question number 35. Due to effect of interference, floating of oil layer in water is visible color. Due to observation of this event, the thickness of oil layer should be, the oil layer thickness should be in terms of millimeters, Nana. Nanometers, sorry, micrometers, nanometers, millimeters, millimeter. So these are wrong answers. This thickness comes out to be, for visible rays, comes out to be 0.1 micrometer. This is a subjective question, director. Okay, remember. Next, question number 'See students, now you are having next 4 minutes time is there. So we will continue in problems next in next class. This coming Saturday again you are having physics exam, no? So for that exam syllabus is For that physics exam, syllabus is wave optics, Nana. Wave optics is the chapter I am going to conduct. On this chapter, I am going to conduct exam. Okay, so prepare this exam. Prepare well this exam. Okay, and today's homework is so Malus law. Yes, what is Malus law? What is Malus law? This right, Nana? And what is Brewster's angle? Brewster's law. Brewster's law. These two important questions. You read them, Nana. Okay? Clear? Yeah. Thank you.